approximately 14,000 employees and 11 manufacturing sites, including offices here in Mexicali. Plus, there are several UABC alumni that are now Honeywell employees. The technologies we develop to support these businesses cover a wide range of technical academic disciplines: electrical, mechanical, aerodynamics, advanced modeling, graphics, human factors, and atomic physics, just to name a few. As you participate in the wide variety of activities today, I would like to encourage each and every one of you to visit the Honeywell technology displays in the theater lobby to find out more about Honeywell. You can view real Honeywell technologies and learn more about the work that we do every day to make the world safer and more secure, more innovative and productive, and more comfortable and energy efficient. The exhibit will be on campus all day today and tomorrow, so please stop by and talk to our Honeywell team. And now, let me introduce our Nobel laureate. Jerome Isaac Friedman is a professor of statistics at Stanford University. He was born in Chicago, Illinois, to parents who immigrated to the United States from Russia. He was especially interested in and excelled in school, and at an early age was especially interested in art. As he grew, his focus shifted to physics after reading a book on relativity by none other than Albert Einstein. So inspired was he by the possibilities in science, he turned down a scholarship to the Art Institute of Chicago to study physics at the University of Chicago. While there, he worked under Enrico Fermi. I'm sure many of you will recognize his name as one of the great experts in atomic physics and also a Nobel winner. Professor Friedman eventually received his Ph.D. in physics in 1956. In 1960, he joined the physics faculty at the Massachusetts Institute of Technology, or MIT. It was in the late 60s, while commuting between MIT and California, when he conducted experiments at Stanford's Linear Accelerator Center. This work was the first experimental evidence that protons have an internal substructure, which later became known as quarks. For this, Professor Friedman and two of his colleagues shared the 1990 Nobel Prize in Physics. Professor Friedman is a member of the board of sponsors of the Bulletin of Atomic Scientists. In 2008, Professor Friedman received an honorary PhD from the University of Belgrade in Serbia. He is an honorary professor at the University of Belgrade's Faculty of Physics, and Professor Friedman also has the distinction of being one of 21 Nobel laureates who signed the Humanist Manifesto in 2003. I know all of you are looking forward to hearing the professor's lecture today and his advice to future scientists and engineers, so I won't delay another minute. Please join me in offering a very warm welcome to Professor Jerome Friedman.
It's certainly a great pleasure to be here at the university and to be part of the Honeywell program. And what really impresses me is the enthusiasm of all the students here. And I am personally very enthused by that. And it's a great pleasure to be able to talk about some of the science that I've been involved with. Now, the question is, are we really made of quarks? Well, I hope you will believe that we are after this lecture, and I want to explain why we believe such an outrageous point of view. So, all stable matter, us, everything around us, is made up of three different types of objects: up quarks, down quarks, and electrons. And just in various different combinations, and that's what makes all the matter that we observe around us. And the question is, how did scientists come to this conclusion? Now, let me tell you, it did not come easily. There was an enormous amount of debate and discussion, and for a long time, the quark model was abandoned as being too outrageous to be considered. Now, physicists have studied the hierarchy of matter. I want to say a few words about that in general. If you look at sort of bulk matter, like a chair or something, it's made of material, it's solid, and let's say we look at it with magnification 1. Now, of course, we now know that bulk matter is made of molecules and atoms, but to study the atom, we must have a magnification which is 100 million. So we have to have an enormous magnification to see the atom. Now, the atom basically consists of a number of electrons going around, which are, of course, negative charge, going around a central core, which is positively charged. And it's sort of what we would call the solar system model of the atom. Now, if we increase the magnification by another 100,000, we can start seeing the properties of the nucleus. And of course, we now know that the nucleus is made up of neutrons and protons.